Hello, hello. So hi everyone, thanks so much for standing by for the sessions with the delay which we are having right now, but I won't be taking that much time since I want to touch upon some best practices and concepts related to one of the very own topic of Kubernetes workloads. So for that, I'll be just touching basing on some of the best ways to optimize your costs. Along with that, you can also use some methods which will save, in your governance accordingly. Talking a bit about me. So I work as a senior platform engineer by profession at Quantify. I also lead AWS user group Nashik, and I am also a part of a program called as AWS Community Builders, and I belong to the containers category there. So I explore and work upon containers more. So I choose to be in that category. So what's the agenda for today? So before I start, rather than directly diving into the best practice, I would like to know how many of you use cluster autoscalers or different scaling methods for your Kubernetes workloads? Yep, I see many of you. So have you heard of Karpenter, or anybody is already using Karpenter? A quick show of hands. Okay, I see a couple of them. For you guys, which you already know, it might be a redundant thing, but yeah, I'm still gonna touch base upon for our other audience. So what is Karpenter? So Karpenter is an Kubernetes autoscaler with some more capabilities, which I will be presenting in further slides. But it is an open source tool by AWS. Also, it is accepted into CNCF's Kubernetes landscape. That means it will be a part of and maintained by CNCF maintainers, which is a great thing for any open source tool to be acquired by a CNCF or be incubated in the CNCF workspace. Now, what are the key features? So basically, as cluster autoscaler is, which helps you autoscale your nodes gracefully, it also helps consolidating your nodes, which in turn saves the costs. Then it has intelligent scheduling. You have options to enable disruptions, how your Kubernetes nodes are gonna disrupt gracefully without running it without any pods, without any workload, and it is in turn again gonna save your costs. And also, as I mentioned, it is cloud native, currently AWS supported, but it can also be extended to GKE or AKS, which is Azure and GCP. But it needs some custom CRDs to be acquired. But if you are already on your AWS workloads, it's gonna help you without any additional extensions to be made into your Helm charts or CRDs. Okay. So again, here is the quick diagram. I'm not sure if it's working, but yeah. So as you can see in the top of the diagram, top half can be seen as pending. There are some Kubernetes pods which are pending, and there are some unschedulable pods. So if you see at the top, there is a scheduler, Kubernetes scheduler, and it is trying to schedule the pods which are running your applications with the existing capacity. So let's say you already have some instance. Let's say for assuming an example, we can take it as a T2 micro instance. So we have a T2 micro instance. There are 4 application pods running. And in the second node, there are 3 actual pods running. So there is one capacity to accommodate one pod. So scheduler will, of course, schedule that pod into the existing capacity. But in the second part, if you see, Karpenter again provisions some just-in-time capacity to accommodate your pending schedulable pods. So that basically creates a consolidation of all the 3 node instances you have, and it creates one optimized instance, be it let's say extra large or large instance, which can accommodate all your pending pods, which becomes more maintainable and also schedules the pods in efficient way. Now there is one more concept which is a base for what are the practices I'm going to tell about. So there's a concept called as node pool. So node pool is nothing but basically how you put constraints on your Kubernetes cluster to schedule the nodes in which your applications are going to run. So here is a YAML file, a config file, which if you can see in the requirements, first you can see there are instance types, and I've put values M5 large and M5 X large. So that means we are telling our Karpenter node pool that whenever you are going to schedule nodes or a new application pods, you will have to select nodes from this particular instance types. It has to be M5 large or M5 extra large. So these are basically constants. So this example is talking about constants, how we can put. So let's say now you have some sort of workloads where there are high GPU capacity needed or high data reference needed. So you can put different constraints on what workload will be running on what pod and what node. And you will have to provide constraints to Karpenter saying that these are the instances you should pick from. So let's say you have heavy GPU operations going on, and you'll need that some extra capacity like GPU specified instances, which you can put in the values, and the Karpenter will definitely choose from those particular instances only. Now coming to the best practices and how to get most out of Karpenter. So there are a lot of ways, but here I have put down a few. As I already explained, there is a best practice called as node pool breakdown, which you can, where you basically segregate your workloads depending on what are your application needs, be it data heavy or a compute heavy or memory heavy. Then there are some use cases where you need GPU power. So you can break down your node pool into that. Again, so as you can see, the metadata says the name as GPU workload. So for my GPU workload, I am asking Karpenter to only choose instances which is P3 to X large. So I have put only one instance which is favorable for me, and I'll be asking Karpenter to just schedule my application pods to this particular instance so that I get full potential power for my applications. And coming to the consolidation part, so consolidation is nothing but Karpenter's smart or intelligent way to basically optimize your capacity. Now, if you see the left-hand side, there is an existing capacity. It's saying the first instance is 2x large, and the second one is extra large. You see that the Karpenter in between is trying to consolidate into more optimal workload. So it is, and also one more thing which I forgot, in the 2x large, there are 2 green pods which you are seeing in the bottom, right? So those pods are gonna scale down, which Karpenter identifies using Kubernetes native scheduler, and it knows that the capacity is not gonna be needed. So it is time for optimization. So at the right-hand side, Karpenter optimized the instance. It shifted from 2x large to x large, 2 extra large containers. And again, the cost of running your pods on 2x large is gonna be more than x large. So basically this is what consolidation means. It is achieved in Karpenter using consolidation policies, which you can read about. And okay, so the next feature here is VPC CNI prefix feature. So everybody knows that in Kubernetes, each pod gets each IP assigned when it gets spin up, right? So using VPC CNI prefixes and add-on, of course, you will need to add on the EKS cluster with VPC CNI extension, and then you will be able to basically set the prefix of /28 rather than /32. So it will help basically assigning IPs more effectively so that your IP exhaustion is properly managed in your node pools. And so based on this particular IP exhaustion, Karpenter will initialize its new node generation and some other aspects of node spinning up, node churn, we can say that. So the next thing is disruption and budgets. So basically you can use Karpenter disruption policies and budget policies to basically terminate, delete, or replace existing nodes with more effective nodes. So as an example, if you see this YAML file, in the budget consolidation policies, when empty or underutilized, that means if any particular node is underutilized, then we are asking Karpenter to reduce that 20% of node load, and for only reasons if it is empty node or drifted. Drifted means changed or replaced by some other node. So yeah, and there are other aspects such as nodes. So you can exactly set percentage-wise count or exact absolute count for how many nodes you want to disrupt when your workload is gonna scale down or scale up. So this is what disruption and budgets are. You can utilize those to, again, save cost. Cost optimization is heavily used in Kubernetes right now because Kubernetes has a lot of advantages, but the common disadvantage which we find talking to the clients is the cost associated with it. So these are some best practices which you can follow to take control of those costs. One more interesting thing is, if needed, and if you know your workload can be short-lived, then you can definitely use spot capacity, spot instances in values. This is the same constant which I talked about in my initial slide, where I decided to use some instances for my node pool breakdown. So I'm asking Karpenter to use spot instances for some of the workloads so that after termination, it's gonna be cheaper for me rather than using on-demand instances. So yeah, you can definitely take advantage of spot instance flexibility. So there are some limitations to watch out for. Karpenter tool is still maturing. By the way, there are a lot of contributions happening nowadays to Karpenter, and it is heavily utilized in the industry as compared to the past couple of years when it was not accommodated into CNCF ecosystem. Then there are, of course, cloud provider limitations. As I mentioned, non-AWS environments might need to set up some additional CRDs or additional extensions to get it working, but AWS has full support, so you can utilize it openly. Then with each of the AWS resources, we know that IAM complexity is always there. You need to take care of least privilege and all those things to properly manage the possibilities of who can access the clusters or nodes, etc. So that complexity is still there, and it's still gonna be a very important one. Also, there are some limitations where you cannot schedule beforehand based on your workloads, saying that, hey, at 5 p.m. I need some more capacity, so please spin up some nodes for me at 5 p.m. It's not possible because it is reactive. So basically, you will have to wait for the actual scale up or scale down happening to your nodes, so that Karpenter take control of that. Hence, it is called as reactive scaling and not predictive scaling. Of course, there is a learning curve, which is not major, I think, because YAML everybody knows nowadays, so it's still fine. And there is always over-provisioning risk. If you miss some constants here and there might be a chance where Karpenter misbehave. It can spin up very heavy instances for small workloads, which will again cost you more. So you'll have to be mindful about those constants what you are putting. So yeah, I think with that, I'll end my session here. If you have any questions, I'll be around. Please feel free to reach out. My LinkedIn handle is Abhishek Wagh. I am Abhishek21 is the alias for the same. So yeah, thank you so much for that, and I'll see you in the expo.